Good morning, everyone, and welcome to this lecture. This is lecture number 2, and we are dealing with work, power, and energy. In the previous lecture, we had seen the work done by a force. Work. What is work done by a force? It is the dot product of force with displacement, or you can write it as force into displacement into cos theta, where theta is the angle between force and displacement. We had seen that it is a scalar quantity and it depends whether it is positive or negative. If the angle between the force is acute, then the work done by the force is positive. If the angle is obtuse, the work done by the force is negative. If the angle is 90 degrees, the work done by the force is zero. Do we remember this? Yes or no? Okay, we had also seen an example where we had found out the work done by various forces. This one, in which we had find out the work done by normal reaction, we had find out the work done by gravity, and we had seen how to find it out. Do you remember this? Yes or no?
Yes, sir.
Okay, then let us go ahead and keep on our discussion on the same thing, and we'll solve more questions. Let us find out the work done. And this is the first question that we are going to do. I hope everyone remembers how to do this. So this is a horizontal floor. I have a body of mass 2 kgs and I apply a force of 10 newtons here. Here friction is also present, and the value of kinetic friction is 0.1. The value of kinetic friction is 0.1. I displace this body from this position to this position. The displacement is given as 5 meters. I displace it by this force. Now you have to find out the work done by the four forces. What are the four forces? Work done by the 10 Newton force, which is applied. Work done by friction. Work done by normal reaction, and work done by gravity. I hope you know how to find it out. Yes or no? You know how to find it out? Okay, then I will give you 2 minutes. Find out the work done by all the forces. Let's see who can do this. Remember, it is the same question that we did in the previous class. You just have to find out the force, displacement, and multiply by the cos of the angle. I'll give you 2 minutes to do it.
Sir, am I audible?
Yes, beta, you're audible. You're audible, beta. Are we trying or shall I help you? Anyone with any answer? Anyone got any answer? No one? Shall I do it? Yes, bacha? No one got any answer? You got the answer? Yes or no? You got the answer? Yes or no? No one got any answer? Have you gone through beta what we had done in the previous class? Do we remember what we had done in the previous class, beta? No one got any answer? Anyone got any answer? For all the 4 parts, any answer anyone got? Okay, no one got any answer. Good. Let me help you out. How do you find out the work done? Who will tell me the formula of work? How do I get the work done? Tell me the formula. Tell me the formula of work done. No one remembers the formula? No one remembers the formula of work done. Am I audible to everyone, beta? No one remembers the formula of work done? Okay, then I'll give you 5 minutes to go through what we had done in the previous class. Remember the formula and then we will work on the problem. I'm giving you 5 minutes to go through what you have done. Only 5 minutes to go through what we have done in the previous class. I think you have not revised it. So you have got 5 minutes now to go through and revise the formula that we have done. I'm going to ask questions to each and every one, and you will have to stand up and give me the answers. I always felt that NEET students are doing better than JEE, but now you have gone in the pit and you are going from heroes to zeros. And you are not at all working hard. And that is horrible. JEE people are way ahead of you guys, way ahead now. And you have gone, it's like falling from a hill. You were up on the hill, way ahead from those guys, and now you have dumped yourself in the pit. I'm very sad to see this. And no one is paying attention, no one reads anything. You've got 5 minutes to go through what I taught you, because no one even knows the formula of work done. But what am I teaching then? No one knows the formula of work done? See, no one knows the formula of work done. Okay, You've got 5 minutes. Read your notes. Have you made notes or not? No one has made notes even. Is that so? May God help you. I mean, God can help you now. No one has made note. No one can tell me the formula of work done. One class has already gone and no one knows the formula of work done. Well done. 5 minutes. Still, I'm hopeful that you will be able to give me the answer. I'm just asking the formula of work done and no one knows the formula of work done. Let me know once you are finished and ready to answer my questions.
Force into displacement cos theta, sir.
Yes? Formula of work done is?
Force into displacement cos theta.
Okay, chalo. Force into displacement into cos theta. Okay. Now I have to find out the work done by this 10 Newton force. This is the 10 Newton force.
50 joules, sir.
So now tell me, how will I find it out? Work done by the 10 Newton force will be equal to the value of force is 10 multiplied by what is the displacement?
5.
5 into what is the angle between force and displacement?
0.
0. Well done. Cos of 0. Cos of 0 is 1. So the answer
Joule.
is 50 joules. So it was so simple. Good. Chalo. We'll move on to the next one. Work done by normal reaction. Who will tell me this one?
0, sir.
Why it is 0, sir? So first of all, let me draw. This is 20 Newton. This is the normal reaction. And the value of normal reaction would be how much?
20, sir.
20, sir. Okay, so let us find out the work done by the normal reaction. The value of normal reaction is 20 multiplied by the displacement is 5 multiplied by what is the angle between normal reaction and displacement?
Cos 90 degrees, sir.
Cos 90 degrees, well done. And cos of 90 degrees is 0. So your answer will be 0 joules. That is your third answer. Well done. Let us move on to the fourth one, work done by gravity. To find out the work done by gravity, I have to find the gravitational force, the weight of the body. How much is the weight of the body?
0 joules, sir.
What a weight of the body is 20 newtons, bhai. Weight of the body is 20 newtons multiplied by displacement is 5 multiplied by angle between weight and displacement. Weight is downwards and displacement is like this is 90. So the answer is 0 joules. This is also done. The only thing that is left now is to find out the work done by friction. How will I find the work done by friction? This one was work done by the 10 Newton force. This one was work done by the normal reaction. And this one was work done by gravity. How will I find the work done due to friction? So first of all, I have to find the frictional force. The body is moving in the forward direction, so friction would be in the backward direction. Can anyone tell me what is the value of frictional force? What is the value of frictional force? No one knows the value of friction force? Frictional force. What type of friction is here? Static or kinetic?
Kinetic friction.
Kinetic friction. Well done. Then what is the value of kinetic friction? How do you find out the value of kinetic friction?
Mu k into n.
Mu k into n. What is the value of mu k?
0.1.
What is the value of n?
20.
So what is the value of friction then?
2, sir.
2, sir. Why you have taken so long, sir? So the value of kinetic friction is 2 newtons. So let us find out the work done by kinetic friction. Work done by kinetic friction. The value of friction is 2 multiplied by the displacement is 5 multiplied by what is the angle between the frictional force which is backwards and displacement which is forward. What is the angle between the two? Frictional force is backwards and displacement is forward. One is backward like this. One is forward like this. What is the angle? Forward, backward. Anyone? When they are in the same direction, angle is 0. Now they are in the opposite direction. So what is the angle? The angle will be 180 degrees. Cos of 180. And you must remember cos of 180 is -1. So the answer becomes minus 10 joules. Do we understand this? How this is done?
Yes, sir.
How many of you do? Is there any doubt with anyone? Boys, girls, please raise your hand if you have a doubt. How this is done? Because the next question, everyone has to do it. Anyone has any doubt? Please ask.
No, sir.
Why are you not able to do it, beta? It's a simple thing. Work power energy is one of the simplest chapters from which you will get simple questions. This is very simple. Can I hope that you can do the next question on your own? Yes or no?
Yes, sir.
Okay, let's hope so. And I'll give you the next question and I'll hope that everyone is able to do it with your own hand. So here comes the next question. Question number 3 or 2, whatever you call it. This is a 5 kg body and applying a force of 20 newtons. And I displace this body by, let us say, 10 meters. The friction is also there. The value of frictional force coefficient is 0.2. So again, you have to find out number one, work done by the 20 Newton force. Number two, work done by normal reaction. Number three, work done by gravity. And number four, the work done by frictional force. You have 2 minutes exactly to do it. Best of luck. And I hope I get answers this time. So, do we have answers?
200 joules, sir.
Okay, so let us start and let us go one by one. Let us go for this work done by the 20 Newton force. What is the answer for work done by the 20 Newton force?
200 Newton, sir.
Work done by 20 Newton force. 20 into 10 into cos of 0. And the answer is 200 joules. Well done. Let us move on to the second one. Work done by normal reaction. What is the work done by normal reaction? What is the work done by normal reaction?
0 joules, sir.
0 joules. Okay. What is the third one? Let us find out the work done by gravity. What is the work done by gravity?
0 joules.
0 joules. Okay, fine. We come to the last one. Work done by friction. What is the work done by friction?
Minus 100 joules, sir.
Minus 100 joules. How did you get minus 100 joules? So first of all, you have to find out the value of frictional force. How will I find out the value of frictional force?
Mu k into n.
Mu k into n. Well done. What is the value of n?
50.
The value of n is 50 and the value of mu k is 0.2. So 50 multiplied by 0.2
10.
becomes 10 newtons. So the work done by friction is 10 newtons multiplied by 10 newtons multiplied by 10 meters multiplied by the angle between displacement and force, and it is 180 degrees. Minus 1, 10 into 10 into minus 1, and the answer is minus 100 joules. So these are the answers. Everyone understands this, yes or no?
Yes, sir.
Boys, do we understand this? Okay, that is great. Let us move on to the next thing, and before moving any further, we have to understand some very simple thing about gravity, work done by gravity, and please note this, work done by gravity, work done by gravity, because this is one of these work done which will be coming every now and then, which is the work done by gravity. Now remember, gravity or gravitational force is a conservative force. Now this is a type of force gravity or gravitational force is a conservative force. Have you heard this term, conservative force? Now, whenever a force is conservative, the work done by that force does not depend on path. So, remember, work done by a conservative force in this case the conservative force is gravity, does not depend on path. Does not depend on path. What do you mean by does not depend on path? If you move an object from point A to point B, and this is a question that has come in your NEET, by different paths, let us say this is path number 1, let us say this is path number 2, different routes, different ways. Let us say this is path number 3. Gravity, which is a conservative force, or any conservative force, the work done does not depend on path. So I can say work done in path 1 will be equal to work done in path 2 will be equal to work done in path 3. Do we understand this? Yes or no? Work done by a conservative force. Gravity is also a conservative force. Work done by gravity does not depend on path. It only depends on its initial and the final position. So you can also write this. Work done by gravity or conservative force only depends on initial and final positions. Where was the initial position and where is the final position? It only depends on this thing. Now remember, how do you find out work done by gravity? Work done by gravity will be always equal to m plus or minus mgh. Work done by gravity will always be equal to plus or minus mgh, where what is h? M is the mass of the body, g is the acceleration due to gravity. What is h? H is the vertical distance the body has moved. H is the vertical distance the body has moved. H is the vertical distance the body has moved. Work done by gravity does not depend on path. It only depends on the vertical distance the body has moved. Now, I have said it can be positive, it can be negative. When it is positive, when it is negative, if the body moves down, if the body goes down, work done by gravity will be plus mgh. If the body moves up, work done by gravity will be minus mgh. If the body moves on a horizontal path, then the body moves up plus mgh, whatever height it has moved. If the body moves down, sorry, I said it wrongly. If the body moves down, plus mgh. If the body moves up, minus mgh. If the body moves on a horizontal floor, then if body moves horizontally on a level road, then what will be the work done by gravity? Tell me. We have solved 3 questions, 4 questions on this. If the body moves horizontally like this, then what is the work done by gravity? In that case, the work done by the gravity we have seen in the previous examples will be always equal to 0 because the angle between force and displacement would be 90 degrees. The work done between force and displacement is 90 degrees. Now you can see some examples when is the work done positive, when is the work done negative. If you have a block of M kept at a height h, if it goes down, the work done by gravity would be plus mgh. Do we understand this? The block moves down, the work done by gravity will be plus mgh. Whether it moves like this or it moves like this, it is kept on a inclined platform. This angle is theta. It goes down and it goes through a height h. It comes down here on this path. Here also, in the first case, the body is moving vertically downwards. In the second case, the body is moving like this. But it doesn't matter. The work done by gravity is always mg into h. If the body is moving down, it is plus mgh. If the body is moving upward, it is minus mgh. Do we understand this? Yes or no? So remember this. Whatever be the path, work done by gravity is always mgh. Moving down plus mgh. Moving up minus mgh. Nothing else. Shall we move ahead? Have you understood this? Okay. Let me now put a question for you. The body is kept on an inclined plane like this. The weight of the mass of the body is 5 kgs, and this is a frictionless surface. The height of the body is 2 meters, and this distance is, let us say, 4 meters. If I keep the body like this, in which direction will the body move? There is no friction. I keep the body on a frictionless surface. Will the body move or will the body not move? Will the body move or will the body not move?
Body move అయితే move కాదని అడుగుతుంది సార్.
So the body is going to move and the body is going to move in this direction. Yes or no? We have to find out what is the work done by gravity when the body reaches the bottom of the incline, and what is the work done by the normal reaction. To find out 2 things, when the body goes down, what is the work done by gravity and what is the work done by normal reaction. Is the question clear to everyone? Yes or no?
Yes, sir.
You have 2 minutes to solve it. Yes, do we have any answer here? What is the work done by gravity? Anyone?
Zero.
Yes?
0 joules, sir.
0 joules, sir. That is wrong, beta. So, I have to find out the work done by gravity. How will I find the work done by gravity, beta? What did I tell you?
mgh.
Work done by gravity will be equal to plus or minus m into g into h. Here is it positive or is it negative?
Positive mgh.
Positive mgh because the body is going down. Mass of the body is 5, g is 10, and the height is 2. That would be the answer. 5 into 10 into 2. The answer would be plus 100 joules. Do we understand this?
Yes, sir.
What about the work done by the normal reaction?
0.
See, whatever happens, the normal reaction will always be perpendicular to the floor and the displacement would always be parallel to the floor. The angle between normal reaction and displacement is always going to be 0. So this answer will remain a 0. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Okay, good. Let me give you one more. A body is here 2 kgs and I move it upwards by a height of 5 meters. So I move it upwards by a height of 5 meters. So I'm moving it like this, upwards. You have to find out what is the work done by gravity and work done by a normal reaction. You have 2 minutes to do this.
Work done by gravity కదా? Work done by gravity is minus 100 joules, sir.
Okay, so I have the answer, yes.
Work done by gravity is equal to 100 joules. Minus 100 joules.
In this case, the body is moving upwards. The work done by gravity is negative. So minus m is 2, g is 10, and the height is 5. So it is minus 100 joules. The work done by normal reaction would be
0.
0 because it is always perpendicular to the displacement. Have we understood this? Yes or no?
Yes, sir.
Let us move on to the next heading.
Yes, sir.
Everyone noted this down? Yes or no?
Yes, sir.
Work done by dot product. So sometimes, and this question comes almost every year in your NEET exam. So please notice work done by dot product. Sometimes force is given as a vector and displacement is also given as a vector, and you have to find out the work done by that force. So how are you going to do this? You don't have to do anything extravagant. If that is the case, you just have to apply this formula F dot displacement. This is how you can find out the work done by the force by the dot product. Now, how will the force be given? Force can be given in this form, Fxi. It will have some I component, it can have some J component, and it can have some Z component. Don't worry, I will give you examples that you will understand then. The displacement would also have X component, the displacement would also have Y component, and the displacement can also have the Z component. What you got to do is you got to take the dot product. Don't worry, how are you going to take the dot product? You just take the dot. How do you take the dot? You just multiply I by I, Y by Y, and J by J, and you just add them. So your answer would be Fx multiplied by X plus Fy multiplied by Y plus Fz multiplied by Z. So that would be your answer. Some of these terms would be positive, some of these terms could be negative, and ultimately you will get the answer from this. Do you understand? I'll give you an example, don't worry. Please note it down. I'll give you 2 minutes to note it down.
Computer, sir.
Okay, then here comes the question. You are given a force and you are given the displacement. You have to find out the work done by this force. I'll give you 2 minutes to do this. Yes, anyone with any answer? So, how are you supposed to do this? Your force is given as 2I plus 3J. Your displacement is given as 3I minus 4J. You have to take the dot product. How will you take the dot product? Multiply this by this, you multiply this by this. So 2 into 3 is 6. 3 into minus 4 is minus 12. So the answer is minus 6 joules. That is your answer. And that is how you have to do it. I'll give you a minute to note it down. If you have any doubts, please ask. Let me know once you are done.
Done, sir.
Then comes the next question. You are given a force 2I plus 3J minus 4K causes a displacement. Displacement is 2I minus 4J plus 3K. You have to find the work done by this force, and I'll give you 2 minutes to do this. I hope you can do this. It's a simple question. 2 minutes.
ఎంత?
Yes, do we have an answer to this one? Anyone?
4, sir.
Oops, what I'm writing?
Minus 20 joules.
How do I get the work done from here? It's very simple. You have to multiply this with this. What will be the answer for this? 2 into 2,
4.
4. You'll have to multiply this by this. What will be the answer?
Minus 12.
Minus 12. You will have to multiply this by this. What is the answer?
Minus 12.
Minus 12. So your final answer is 4 joules. Is it? Do we understand this? Yes or no?
Yes, sir.
Well, that brings us to an end of this class. We have dealt with work done by a constant force, and I hope you have understood this. We've also seen how to find out the work done by gravity. If something is going down, work done by gravity is positive. If something is moving up, work done by gravity is negative. If something is moving on the horizontal, the work done by gravity is 0. Do we understand this, everyone? In the next class, we'll move ahead and we'll do some more problems on constant force, and we will move on to when the force is variable as well. So take care, and I'll see you in the next class. Bye bye.
Bye, sir.